Okay, I hope all of you have this set of notes. Okay, we'll be going through general wave properties. Last time, before the change in syllabus, this is about transverse waves. Okay, so part 1 is on transverse waves. Later I'll explain to you what's transverse and longitudinal. Part 2, it is on longitudinal wave. And the only longitudinal wave in our example is sound. Is sound. So when do you know it's longitudinal? When do you know it's transverse? Once you see sound, it must be longitudinal. Example of transverse waves will be your microwave, light, and water waves. Okay, later we'll see some examples. Okay, let's continue. So these are the success criteria for part 1, A to E. I have already blocked out the rest, the gray out one. They will appear in general wave property 2. So these are the 5 success criteria you need to know. Okay, let's see how far we can go. We are left with about one more hour. Okay, so success criteria A, describe what is meant by wave motion as illustrated by vibration. So this vibration is actually a keyword. Okay, and later on you will see this thing called wavefront. So wavefront is a term. So we have wave motion that is caused by vibrations, and later on a term that we will be using in wave will be called this thing called wavefront. So what is wave? A wave is a transfer of energy from one point to another by vibrations. So basically it transfers energy. Okay? So wave particles will be in their rest position if there are no vibrations. If there's a disturbance, they will then vibrate in their respective directions and with various displacement from their rest position. Okay, how do we create a wave? There must be either vibration or oscillation. Okay, are you underlining all this? Okay, waves can be produced in water using a ripple tank and a wave generator. Have you seen this kind of wave before, circular? You go to Bedok Reservoir, you throw a stone. What will happen? There will be a they are not allowed. They are not allowed. Okay, you throw something in your bathtub, or you throw something in your big bungalow swimming pool. You will see that there is circular wave, but we can also make straight edges waves. Okay, so besides circular, we can also make straight waves. All right. So this is what happens. This is the dipper at rest. I'm not sure how the printing is for your notes. So before that, there was no vibration, nothing. So the water particles, they will remain at rest, in their rest position. But later on, when the dipper starts moving, it creates a vibration. The particles here will also vibrate about their fixed position. Okay? So best way to do here is move in their respective position. They transfer energy, but they do not transfer the particles. Meaning, if the 5 of us, if just now we hold hands, and we make waves, right? Where will we be after we make waves? We'll still be here. We cannot say, hey, come, let's go Bedok Mall. Then we like, oh, let's do wave. After that, we find ourselves, we end up at Bedok Mall. Wow, it won't happen. The particles will still be around. Okay? Now, the waves can also be created using a rope. Okay, so now we'll use slinky. Are you all writing? If it's longitudinal wave, you think of the keyword parallel. Then you substitute in the direction of wave propagation is parallel to direction of vibration of particles. Simple. Can also perpendicular, you think of transverse, or transverse think of perpendicular. Longitudinal, you think of the word parallel. Okay, are you able to find this definition? Are you able to find this definition? What is wavefront? You need to memorize this. This is the definition of wavefront. What basically it is an imaginary line that joins all adjacent points on the wave that are in phase. Okay, I haven't gone through what is in phase yet, but later on I'll go through more details on wavefront. But you just take note that the formula, the definition is this. I haven't gone through what is crest, basically the terms that we use in wave. Later on I'll go through. Okay? We end at 3 leh. No leh, 210, 210. Okay, the longer we take to talk about this, the longer I will have to hold your back. So the motion of any selected point in a wave is periodic. Where have you heard this thing called periodic? In pendulum, right? So the pendulum can also be creating some kind of wave. It is periodic and repetitive. Okay, this motion is known as vibration or oscillation. Right? Move on. Okay, show an understanding that waves transfer energy without transferring matter. Okay, when a wave propagates out of its source, the medium's particle do not get transmitted out from a source. They just vibrate about their rest position. What is radiating out, what is being transferred or transmitted is the energy. Okay, energy is being transmitted. For transverse wave, we need to know there's a certain kind of questions. Okay, let me show you now. Okay. This is a wave particle. This is a particle on the wave. Do you know what is going to happen to this particle? It will come back down. Why? Because it's already at its maximum height. So it will come down. Okay? Can I? How about this guy? Confirm? You go up. How about this guy? Go up or go down? Okay, now we do one exercise. Now the systematic way is that the wave, let's say, is going to the right. So this is the wave direction. I must tell you whether it is going to the right or to the left. If the wave is going to the right, will it still change the fact that this guy is going down? It wouldn't. Will it change the fact that this guy is going up? It wouldn't. Right? It wouldn't. So now, step 1. You need to know the wave direction. Are you writing this down? Just draw a very simple wave. So step one, you need to know the wave direction. In this case, what is the wave direction? To the left or to the right? To the right, huh? Can the question say the wave is going to the left? Can they come out with a question that say wave is going to the left? Yes. So if you know that the wave direction is going to the right, next step is draw next wave according to the wave direction. How do I draw the next wave? You must copy this down. So draw the next wave according to wave direction. Is the wave going to the left or right? To the right, huh? So I'm going to draw the next wave using another color. Okay. Is the green color dotted wave to the right side of the original wave? Is it according to the direction of the wave? Yes, right, to the right, so I draw the green color dotted wave. Okay, so from your drawing, I know whether you are good in art or not. I've seen some students, wow, the wave go all over the place, but roughly like that. Okay, but actually some of you can visualize. So this drawing part, maybe as a start, you try drawing first, but later on, some of you can actually visualize how the wave is going to look like. So this is step 2. Are you able to draw the next wave according to the wave direction? Can, right? Okay, so now, once you have drawn it, who is the particle that we want to know? Whether it goes up or down. This one, right? This guy, this red color dot, So, step 3. Step 3. Are you drawing this? Draw a vertical line from the particle to see where it intersects with the next wave. That's the method. Okay, it shows the profile of part of a wave moving from left to right. So the wave direction is left to right. So in order to solve this, what must I do? Draw the next wave, right? I could be an art student. P is permanently at rest. Can or not? Hey, sports cap. Imagine you ask them do wave, then the person permanently at rest. Cannot lah. You are like, hey, why you not doing this? Correct? So P is not permanently at rest. P is at the rest position, but it is not permanently at rest. Okay, I'm going to add on to this question now. Yes. Come. Okay, T is at the highest point. The speed of T 0. Why? Because it has reached the So the speed of T is 0 because it has reached the highest point. Who else has 0 speed? this guy, and this guy. They all have zero speed. Who has the maximum speed? P, Q, R, or S? Who has the highest speed? P and R. P and R has the maximum speed. You draw your, imagine, remember your pendulum? At which position does the pendulum have zero speed? At the highest point. Where does the pendulum have the maximum speed? The lowest point. And if let's say the pendulum is not moving, the pendulum is not moving, this will be the rest position. At the rest position, it may sound like very contradicting. At the rest position, the speed is actually the highest if it's already moving. Default, wow. I don't know whether they'll write this in textbook or not. But this is what we know as the rest position when it's not displaced. Right? For pendulum, where does it have maximum speed? When it's at the rest position. So we can draw parallel to this for our wave. When the wave particle is at the rest position, it is not at rest, you know. It is only at that position. The speed is actually maximum. Okay? And let's move on. This one, what will happen to Q? Anyone can do it without drawing. Wow, so fast ah. Up or down? Okay, Glenn Yong, up, up. Okay, I'm just going to test it. I can't. Maybe you can think of a way. For me, I always draw the next wave. Then after that, I see where it cuts, so it will move up. Okay? So always take note of the direction of the wave. Okay, now we compare transverse and longitudinal wave and give examples of it. So you have just seen from the slinky, okay, so they are parallel, for transverse wave is perpendicular. Okay, so these are the examples, you need to know a few. But for longitudinal, the keyword is parallel. They only have one example called sound. Okay, so once you see sound, you know that it is longitudinal wave. Okay, state what is meant by wave motion. This is what was mentioned at the start of the lesson. And describe how water in a ripple tank, this one, okay, describe how water in a ripple tank provides an example of transverse wave motion. So they are asking us, how does it show that it's transverse? So transverse, what do you think of? Perpendicular, right? So when a vibration in the water causes the water particles to vibrate, they move or vibrate in a direction perpendicular to the direction of propagation of the wave. Okay? So basically, it is testing you on the definition of what's transverse wave, but just putting the water waves as a context. Can? Okay, answer for E2 is D because sound is longitudinal. All right. Okay, success criteria C. Okay, we will have two graphs, but you don't need to calculate gradient. I know you all are very traumatized by your kinematics graph, but here we don't need to do gradient. In fact, the graph very simple, but you listen to me. Okay, we have a few terms that we need to know. What is crest? Crest is the highest point in a wave. Have you all seen a toothpaste brand called Crest? Last time before I taught physics, I didn't know why called Crest. Then now I know because your tooth, the highest point, right? You want it to be nice and shiny, right? Very nice, right? Your tooth. So they call the toothpaste Crest because they want to make sure that that's only my own interpretation. Never mind, never mind. So anyway, crest is the highest point in a wave. Okay? This term called trough. Trough is the lowest point. So A, B, and C are crest, X, Y, and Z are trough. Are you underlining this? Now, what is amplitude? It is the maximum displacement of a wave particle from its rest position. Listen to this. From rest to crest is the amplitude. From rest to crest position is the amplitude. Rest to crest, it rhymes. Never mind. So what's the amplitude? Rest position, vertically go up to the crest, that will be your amplitude. Okay? Can we go from rest to trough? Will it be of the same amplitude? Yes. In our syllabus, our wave will usually look like this. Very symmetrical. They wouldn't do things like this. Wait, they wouldn't do things like this. They won't do things like this. Okay, they won't do ugly waves like this. It will usually be quite symmetrical. Okay, so from rest to crest is actually the amplitude. Okay, what is the trick that teachers like to trick you all? I do this. I provide a number here, 40 meters. Then they ask you, hey, what is the amplitude of this wave? What will students do? Without thinking, they will say 40 meters. Because the answer, the number provided for them. But what they need to do is 40 divided by 2, so it's 20. Are we okay? So crest, trough, and amplitude done. Now wavelength is this thing, this symbol is called lambda. Okay, this actually looks like a Chinese character called Ru but never mind. Now we call it lambda. So lambda represents wavelength. What is wavelength? Wavelength is the shortest distance between two particles that are in phase. What does it mean by in phase? In phase means same displacement, they have the same movement, same direction of movement, and they have the same speed. So now I will test you. P. Wait. A and B, are they in phase? Is A and B in phase? Why? They have the same displacement. What is the direction next? Down. B is also going down. Right, and they are the same speed. At this highest point, their speed is 0. Okay, how about X and Y? X and Y in phase? Yes. How about A and X? Why left, what is different? A is going to go down, X is going to go up. Very good. Very, very good. How about P and Q? Are they in phase? What's their amplitude? What's their amplitude? Their direction is different. Although amplitude is the same, is 0, but the direction is going to be opposite direction. So they are not in phase. Who is in phase with P? P and R, they are in phase. They have the same amplitude, which is 0. They have the same direction of motion, and they have the same speed. So you all understand in phase? Can I? Please memorize this. You can either say wavelength is the shortest distance between two wave particles that are in phase, or wavelength of a transverse wave can be defined as the distance between two successive crests or troughs. You all know what is successive? One after the other. The next one closest to it. Okay, SI unit of lambda is meters. Okay, so now I will end off with this called DD graph. We are dealing with this. DD graph, two things that are important. Please write this down. DD graph. Y-axis. The first D. Y-axis. The first D is displacement. Y-axis. What can you get from the Y-axis? You can get amplitude. That's it. Full stop. Enough. You can only get amplitude from the Y-axis. What can you get from your X-axis? X-axis is distance. Distance, what can we get from distance? We can get wavelength. So DD graph, very simple. What can you get from the first D? Amplitude. What can you get from the second D, which is distance? Wavelength. Okay, I will let you all go if you can answer my next question. Okay, so in order to be able to find your wavelength, your lambda from your x-axis, you need to identify one complete wave. One complete wave, because one complete wave is the distance that the wave has traveled. Okay, I give you an example. If I start here, the purple color. You tell me, when is it a complete wave? Tell me when to stop. Oh yeah, too late. Too slow. Better focus. Tell me when is it a complete wave? Stop. It was so close. I want to raise a stake higher. I start at A. Tell me when is it a complete wave? Oh my God! You didn't stop me. I'm sure you all know how to get the wavelength, right? Can So you need to identify what is a complete wave With that, you can identify, you can map it to the axis below. Okay, so we have done DD graph, we will be doing DT graph. Now, your holiday homework, I'll be recording video of DT graph and subsequent notes. Okay, make sure you have your wave tutorial. Okay,